Well, hi, everybody. My name is Josh Preston. I'm just graduated here in 2018, and I was kind of joking with my boss a little earlier that I get to pull the card that I'm still an undergrad, so you can't critique my research as much, but I'm technically getting an alumni spot for the presentation. So I'm kind of in limbo right now. Well, it looks like I had some animations here, but they didn't go through, but I'll go ahead and make the jokes without the animation. So I grew up in Jessamine County, Kentucky, went to West Jessamine. If you would have asked me what I wanted to do at Kentucky in high school, I probably would have said play football. There is a picture of me playing football hidden under that picture of Josh Allen. Turns out UK is a lot more interested in other Joshes that are a lot less skinny than me to play football. So I was stuck on the sidelines there to watch the game, which is fine, but I was a lot more talented, I think, in the lab than I was on the football field, as you can see down there with the mice. I developed my interest here at Kentucky. Like I said, I graduated with a degree in biology, and I came in pretty gung-ho to want to be a physician when I grew up. My dad was a physician, and I was very inspired by him. But as I started working for Dr. Pearson, originally just to build my resume and to get into research, I found that I really did love the idea of research, the idea of discovering, and I decided to pursue my MD PhD, which I'll be doing at Emory University this fall. And of course, I'd like to thank Dr. Pearson. Has been an incredible mentor for me for the past 4 years, my family, my faith in Jesus Christ, and of course, the University of Kentucky has been unbelievable in preparing me and helping me get to this point. So now to tell you just a little bit about a recent project I've been working on. So if I told you today, I could tell you what day you were going to die, would you want to know this information? Well, I think regardless of what your answer to this question is, some may say yes and some may say no. From an entrepreneurial standpoint, I think this is an interesting question. When we think about clinical diagnostics, clinical medicine, if we can determine somebody's biological age, there's a difference between chronological age and biological age. Chronological age, of course, is being the amount of candles on the cake at each birthday, but biological age is something a little bit more complicated. It's how old your cells are, how old your tissues are, and how soon you will expire. We could be in the room and both be 50 years old, though one person could have the health of a true 50-year-old and not one of an 80-year-old. So because of that, there's a pressure to develop what we call biomarkers of aging. These biomarkers simply something that comes from an organism that can be used to tell about the state of the organism. And so there are many different potential biomarkers of aging, but one that our lab is interested in is called Chemrin. I'm happy to talk to you guys later about what this does in detail, but I'll save you the details. Essentially, Chemrin is what we call an adipokine. It's a cytokine that is secreted from adipose tissue, and it can induce inflammation. So as our cells age, they go into what we call senescence. When cells become senescent, they start to secrete these cytokines. They don't divide as much, but they start to secrete cytokines. So we wanted to look at Chemrin potentially in the context of aging. We hypothesized that as these mice increased in age, so would the blood Chemrin levels, using it as a biomarker of aging. We got these mice from the National Institute on Aging cohort in Baltimore, and you can see here with our results there is a significant increase in age. In the males, in the red there, and then in the green is the old males, and you can see a significant increase of age, and especially in the females, it's a remarkable increase. They becomes very dysregulated towards the end of their life. So what, in fact, is the market application of this? Well, of course, like I said, aging and aging research is a very inherently entrepreneurial thing. Something has to keep Don Witt looking this young through 5 UK presidents, and so I think we're willing to pay a lot of money for these kind of things. So I envision a day in the future where we could take things like blood, saliva, maybe skin biopsies, DNA, in a standard clinical visit, and have what we call a biological age kit, something to run and be able to tell a patient or a laboratory animal what is its true biological age? How long does this organism have left to live? I envision these things being things like cytokines, DNA methylation, telomere length, adipokines, or misfolded proteins. And of course, if our research is robust enough to add Chemrin to this panel of things. We're in the process currently right now of looking at this in humans and also in monkeys across the lifespan, and we hope that our results replicate our results in mice to eventually hopefully establish this as a diagnostic biomarker of aging. Thank you.